Hello everyone. Today we will see the next concept of fourth modulo, that is test for convergence of series of positive terms. As I said in earlier class while we are discussing a remark, that is we have to employ various tests which are established from the basic definition of convergence and divergence of an infinite series. Means it will not always be possible to find the nature of an infinite series as in the earlier example. Means in the last class we are solving some examples to find the nature of the given series. Means that method is not possible in all the times, so that we have various tests which are established from the basic definition of convergence and divergence. And the tests are, first one, Cauchy's root test and D'Alembert's ratio test. Here we have two tests. First see the first one, Cauchy's root test. What it says is, if summation un means what is the sum of first n terms. We know that un indicates what? Nth term of the series. This summation indicates what? Sum of the first n terms. Un indicates summation un indicates what? Sum of the first n terms. If summation un is a series of positive terms, and if limit n tends to infinity, un raised to 1 by n is equal to L, means this L value will be a finite value, then the series is convergent. If L is less than 1, means this limit n tends to infinity, un raised to 1 by n value is less than 1, then we say that the given series is convergent. And divergent if L is greater than 1. If this value is greater than 1, then we say that the given series is divergent. And we have another result here, that is, and the test fails. It means that Cauchy's root test fails if L is equal to 1. According to this test, the given series is convergent if limit n tends to infinity, un raised to 1 by n is less than 1, and divergent if limit n tends to infinity, un raised to 1 by n is greater than 1, and if limit n tends to infinity, un raised to 1 by n is equal to 1, then the test fails for the given series. Next, we have note here. We can try to apply this test if un is of the form f of n raised to g of n. It means what? We can apply this result, means this result when given a un term, means given nth term is of the form f of n raised to g of n. Second one, the following standard limits will be useful. First one is limit n tends to infinity, n raised to 1 by n is equal to 1, and second one, limit n tends to infinity, 1 plus 1 by n whole raised to n is equal to e, where e is numerically equal to 2.7, and the third one is limit n tends to infinity, 1 plus x by n raised to n is equal to e raised to x. See, these two results are same, but here the difference is in place of 1 we have x here. If we replace this 1 by any term, then it will be e raised to that term. Okay, remember this too. While we are solving, these results are very useful. In solving an example, if you get the terms like this, directly you can apply these results. So remember these results. Now let us see the example. First one, find the nature of the series summation n running from 1 to infinity a raised to n square x raised to n where a value is less than 1. This is our given example. Here they are given a series summation n running from 1 to infinity, summation n running from 1 to infinity a raised to n square x raised to n. This indicates what? Our summation un. This indicates what? Summation un according to our statement of Cauchy's root test. This indicates what? They are given nth term, sum of nth term here, that is summation un, where the a value is less than 1. Solution by data un is equal to what? A raised to n square, a raised to n square x raised to n. Okay. Now according to Cauchy's root test, we have to find first un raised to 1 by n. Then we have to apply limit for that un raised to 1 by n. Before applying the limit, we will find un raised to 1 by n. What will be the un raised to 1 by n? It will be what? A raised to n square whole raised to 1 by n. We can write separately here x raised to 1 by n, which is equal to, it will be n square divided by n means, otherwise I will write clearly, n square divided by n into x raised to, here we have already n here, n divided by n, which is equal to what? A raised to n into x. Therefore summation un raised to 1 by n value is a raised to n into x, a raised to n into x. Now apply limit for this one. Limit n tends to infinity un raised to 1 by n is equal to limit n tends to infinity an into x. Here we have to apply n as a infinity, and we know that this a value is less than 1. This a value is less than 1. Therefore here a raised to n tend to 0 as n tends to infinity, since a is less than 1. Remember this, if a here a is less than 1, therefore a raised to n tends to what? 0 as n tends to infinity. That is if this is 0, a raised to n value is 0, 0 into something is again it is 0. Therefore limit n tends to infinity un raised to 1 by n is equal to 0, which is what? Which is less than 1. This is value of L and which is less than 1. We know that according to Cauchy's root test, if the given means our answer is less than 1, the given series will be convergent. Thus by Cauchy's root test, summation un is convergent. This is how you have to find the nature of the series using the concept of Cauchy's root test. Next, second example, discuss the convergence of summation n running from 1 to infinity 1 plus 1 by n whole raised to n square. Solution by data. From this what we conclude, un is given, that is 1 plus 1 by n raised to n square. Similarly, here also, before applying the limit for un, first we have to find what? Un raised to 1 by n. According to our Cauchy's root test, un raised to 1 by n is equal to 1 plus 1 by n raised to n square whole raised to 1 by n. Whole raised to 1 by n means it is what? 1 plus 1 by n whole raised to n square by n. N square by n means it is 1 by n. Therefore, un raised to 1 by n is equal to 1 plus 1 by n raised to n. Okay, now apply limits here. Limit n tends to infinity, un raised to 1 by n is equal to limit n tends to infinity 1 plus 1 by n raised to n. See, this is our what? Standard result. We know that limit n tends to infinity 1 plus 1 by n raised to n is what? This is e, and we know that this is numerically equal to 2.7, which is what? This 2.7 is this is greater than 1. 2.7 is greater than 1. We know that if our given series divergent, if limit n tends to infinity, un raised to 1 by n is greater than 1. Therefore, this series is divergent. Remember, according to Cauchy's root test, if this limit value is greater than 1, the given series will be divergent. I will write conclusion here. Thus, the series is, otherwise you write, thus according to the Cauchy's root test, the series is divergent. I will simply write, thus the series is divergent. Remember the process here. Next example. Third example. Test for convergence of series summation n ranging from 1 to infinity 1 n plus 1 divided by n whole raised to n square into 1 divided by 3 raised to n. Solution. By data. Solve same as the previous examples. Here un is given, that is un is equal to n plus 1 divided by n whole raised to n square into 1 divided by 3 raised to n. Next step is we have to find un raised to 1 by n. un raised to 1 by n is equal to n plus 1 divided by n raised to n square raised to 1 by n into 1 divided by 3 raised to n whole raised to 1 by n. Now we know that n square by n is n by n is 1 here, so that it will be n plus 1 divided by n whole raised to n into 1 by 3. This is un raised to 1 by n. See, what will be our next step here? Next step is we have to apply the limit. See, when we apply limit here, okay, first I will apply limit, then I will explain you why we take this term in a different way. Okay, limit n tends to infinity n plus 1 divided by n whole raised to n into 1 by 3. See, this 1 by 3 doesn't have any n term. You can take this 1 by 3 outside the limit. Okay, otherwise write here only. See, when we apply limit for this one, what we will get? Infinity plus 1 divided by infinity raised to infinity. Means our this infinity and infinity into something is again a infinity value. Means what? We get limit n tends to infinity un raised to 1 by n is equal to infinity. But according to our Cauchy's root test statement, we get limit n tends to infinity un raised to 1 by n, which is equal to L, which is a finite quantity. See here, according to Cauchy's root test, limit n tends to infinity un raised to 1 by n is equal to L, and this L is what? Finite quantity. But we get infinity here. Okay, to avoid that one, see, limit n tends to infinity. See, this term can be written as 1 plus 1 by n raised to n. See, this is a term which is obtained by taking the LCM of this term. Right? When we take this LCM, again we will get what? N plus 1 divided by n. We will take the simplified form of this one, that is 1 plus 1 by n raised to n into 1 by 3. We can write this as 1 by 3 into, since 1 by 3 is a constant, limit n tends to infinity 1 plus 1 by n raised to n. And from our standard result, what we know that limit n tends to infinity 1 plus 1 by n raised to n is e, means it is e by 3. Here I will write 1 by 3 into e. 1 by 3 into e is e divided by 3. We know that this is what? 2.7 divided by 3. When we divide this one, we get a value which is less than 1. Right? Why? When we solve this one, first we have to take the point. After that we will solve this 2.7 by 3. Therefore, the value which is obtained by 2.7 by 3 is less than 1. And we know that according to Cauchy's root test, limit n tends to infinity un is equal to a finite quantity which is less than 1, then the given series is convergent. We will write thus by Cauchy's root test. I will write in short, but you have to write in right way, means write particularly Cauchy's root test summation un is convergent. Summation un is convergent because here our limit value is less than 1. Next example, test for convergence of series summation n running from 1 to infinity 1 plus 1 by root n whole raised to minus n raised to 3 by 2. Solution. By data, we know that un is given, that is un is equal to 1 plus 1 divided by root n whole raised to minus 1 raised to 3 by 2. Okay, you can write in a square bracket or open bracket, both are same. Then we have to find un raised to 1 by n. is equal to 1. Before that I will take a bracket here. 1 plus 1 by root n raised to minus n raised to 3 by 2 whole raised to 1 by n. Then un raised to 1 by n is equal to 1 plus 1 divided by root n raised to minus n raised to 3 by 2 divided by n. When we solve this one, it will be what? N raised to 3 by 2 minus 1. Here, because here n value is 1, it will be 1 plus 1 divided by root n raised to minus n raised to 1 by 2, because 1 by 2, 3 by 2 minus 1 is 1 by 2. Un raised to 1 by n value is what? 1 plus 1 divided by root n. Next I will write un raised to 1 by n value again here. That is 1 plus 1 divided by root n raised to minus n raised to 1 by 2. See, this can be written as 1 divided by 1 plus square root of n whole raised to minus n raised to 1 by 2 can be written as root n. Okay, then we know that anything raised to minus into something is 1 divided by that term raised to something here. Therefore un raised to 1 by n is equal to 1 divided by, because here we have a negative value, it will be in a denominator, 1 divided by 1 plus root n raised to root n. Okay, this is our what? Un raised to 1 by n. Now we will apply limit here. Limit n tends to infinity, un raised to 1 by n is equal to limit n tends to infinity 1 divided by 1 whole divided by, again 1 divided by 1 plus square root of n whole raised to root n whole raised to root n. See, this result means this term is same as limit n tends to infinity 1 plus 1 by n whole raised to n is equal to e. See, this result, this denominator term is same as what? 1 plus 1 by n raised to n. Simply we have in place of n we have root n, 1 divided by 1 plus root n whole raised to n. Therefore we have, this will be limit n tends to infinity 1 divided by, this means what? Limit n tends to infinity 1 divided by limit n tends to infinity this term. This is the meaning. When we apply limit n tends to infinity to this term, we will get what? E. Because in place of n just we have root n. See, in both the places we have the same term, so that we can apply this result here. It will be what? 1 divided by e. It will be limit n tends to infinity un raised to 1 by n. Then 1 divided by 2.7. We know that e value is numerically equal to 2.7. When we simplify this one, we get this value is less than 1, not greater than 1. This value is less than 1, because in denominator we have a greater value as compared to numerator. We get this value is a less than 1. Therefore, or the conclusion, thus by Cauchy's root test, summation un is convergent. Summation un is convergent. Fifth example, discuss the convergence of summation n running from 1 to infinity n plus 1 raised to n into x raised to n divided by n raised to n plus 1. This is what? N raised to n plus 1. Solve this example yourself in the online class, means in live class I will see your answers. All of you must try this example. Solve this one same as the previous example. You will get a result. Write down the notes and understand the statement of Cauchy's root test, and remember these 3 results. These are most important while solving the examples, and I have solved 4 examples here. Go through one by one. These are very simple examples. If you understand how to solve these examples using Cauchy's root test, you can solve many more examples in examination. Remember what are the steps involved here. First you have to identify what is given, and you have to write the un term, means nth term of the given series. Then you have to find what is that nth term raised to 1 by n. Then apply limit for that, means limit n tends to infinity un raised to 1 by n. If that value is less than 1, then according to Cauchy's root test, that given series is convergent. If that limiting value is greater than 1, then the given series is divergent. Here we are not solving any example for test fail condition. Okay, we have only convergent and divergent conditions here. In examination they may given for test fail condition also, but one thing is you have to simplify this in the same way, means using these steps you will get a correct result. In these examples you are very careful when you are finding un raised to 1 by n, and if you don't know how to apply these limiting values when you get something raised to n tends to infinity, as n tends to infinity, and something raised to n tends to infinity as n tends to infinity. If you don't know those concepts, just go through the previous classes and do not absent for live classes. This time attendance is very compulsory, and from the next class all of you must join with your USN number. Okay, it may take lot of time to convey you. In the live classes only that you can you have to change your USN number, name by USN number. We don't have much time for this, much time to solve your doubts, so that please join with your USN number and write your doubts in one page. We will solve in live classes only. Please write notes and understand all the concepts. Okay.